In this video, I am going to solve a problem about application-related rates.
So let's start with this problem. A tank of water in the shape of a cone is leaking water at a constant rate of 2 cubic feet per hour. The base radius of the tank is 5 feet and the height of the tank is 14 feet. At what rate is the depth of the water in the tank is changing when the depth of the water is 6 feet? So let's start with this step. We write the given of the problem, that is the volume. So we write dV over dt equals negative 2 cubic feet over hour. As you can see that the sign changed into negative because we can see in the problem that it is leaking. Next is we need to find the change in the height in the depth of the water. So it is asking for the rate depth of the water is changing when depth of the water is 6 feet. So we need to find dH over dt when h is equals to 6 feet. So at this point, we draw a cone and the radius of the cone is 5 feet and the height is 14 feet. So we are dealing with volume of the cone, so we write the formula for the volume of the cone. That is V equals 1 over 3 pi r squared times height. Whenever you've got this scenario and trying to find the dH dt, it's going to be easier if we put this equation all in terms of t because we're trying to find a dH over dt. So I can do that using a proportion and write the relationship between radius and the height, and we usually do that with a proportion. So we can do the r over h is equals to 5 over 14. We can cross multiply down and choose to solve for r because we want to replace r, so that's we've got everything in terms of h. So we have 14r is equals to 5h and divide both sides by 14 and we simplify that, so we got r is equals to 5 over 14h. And that is what we're going to do because we're going to substitute the value of r. So we write V is equals 1 over 3 pi. So we're gonna substitute the r here. That is 5 over 14h squared times h. At this point, we simplify this equation. V is equals to 1 over 3 times 25 over 196 h squared times h. And we've got the V is equals to 25 over 588 pi h cube. At this point, we simplified formula and now we can implicitly differentiate with respect to time. So that V is going to be dV over dt is equals to 25 over 588 pi. So we can get the derivative of h cube, which is 3 times h squared times dH over dt. So we substitute the value of dV over dt, that is negative 2 cubic feet over hour, equals to 75 over 588 pi times the value of h, which is 6 feet squared, times dH over dt. So negative 2 cubic feet over hour is equals to 75 over 588 pi, and then 6 times 6 is equals to 36 feet squared dH over dt. So next is negative 2 feet over hour is equals to, we're going to multiply 75 over 588 to 36. So 75 times 36 is equals to 2,700 pi cubic feet over 588 dH dt. So we've got an equation here. So we are going to be multiplying by the reciprocal. So it is going to be negative 2 feet cube over h times 588 over 2,705 feet cube is equals to dH over dt. So we are going to cancel the feet, and it is going to be dH over dt is equals to 49 over 225 pi times negative 2 feet over hour. And then dH over dt is equals to 49 times negative 2 is equals to negative 98 over 225 pi feet per hour. And this is our final answer. So I conclude that at 6 feet, the depth of the water is changing at a rate of negative 98 over 225 pi feet per hour. And that's how we solve this problem.